Sorry, like it again got disconnected somehow. So yeah, as I was mentioning that this is another strand. So in the similar structure, we have this, then we have this, then we have the sugar, like the similar structure strand, we have the sugar over here. We have phosphates, this is sugar, this is again sugar. We have phosphate here. Okay, now just saying, or what I did actually solve the example. So this was actually the example given. So they were like the filling part, like this were the blank part. Okay, like the portion, which are, let's say this portion, these are the blank portion. They wanted to know that what are these. So you needed to fill them up. I solved it for you, because in my paper, like it wasn't written anything. So yeah, you got the gist, you got the answer. So everything was like correctified. I would urge you to, like, if possible, to like keep it blank and try to solve it. But yeah, it's fine. Like you at least got it, like how now these things works. Okay, so like how would you have you recall like which one should be the which one? You obviously know this is phosphate, it should be phosphate because sugar is mentioned there. Even if sugar wasn't mentioned, you could have like guessed, okay, this is sugar, those are phosphate, these are phosphate. You could have like guessed for, that's a phosphate. Here we have phosphate. We have PHOSPHATE, phosphate, phosphate. Okay. And how could you recall, like, or how can you identify which one is thymine, which one is adenine, which one is glycine, which one is like cytosine? Remember, recalling on the type of bond. If this is double bond, then thymine and adenine. Either way is like preferable. AT or TA, which one you draw, it's completely fine. Let's say we, like previously I gave here what, like T on the topmost part and A on the bottommost part. Let's say, let's replace it. Let's say T and A is here, okay? And here I like just sometimes before, like I gave here G and here C. So let's give G and C here. Completely okay, all right, because nothing changes, just the position changed. But the bond is like, what matters is the guanine, guanine, isn't it? Sorry, glycine, not it's guanine. Yeah. Guanine is going to react with what? Cytosine. The triple bond, depending on the triple bond, we would confirm that guanine and cytosine, they're reacting or they're forming bond. Similarly, adenine and thymine should be forming bond in between them. Okay, now we are so far actually done with our DNase portion. We are going to move on to our actually electrophoresis. Electrophoresis is mainly electrolysis, but in a different approach. Like electrophoresis, taking the concept of electrolysis, we use it to separate like substances present in, let's say, mixture. So what is the topic? Electrophoresis. Phoresis. Yeah. Okay. Now, what does this electrophoresis means? It means actually, or specifically, that special component is the amino acid. So it is a mean, or it is a way of separating amino acids from a mixture of amino acids. So that means an amino acid can contain what we mentioned. Let's say we can have glycine, adenine. We can have glycine. We can have alanine. We can have aspartic acid. We can have cysteine. We can have serine. We can have lysine. So those could be present in a like mixture of amino acids. So it is a process of separating all those like type of amino acids from there. Okay. So now how do we do this? We specifically do this because obviously amino acids does not, like, if let's say mixture of amino acids present there, obviously we're not going to get that like amino acid as pure. Why? Because amino acid do what? They react with each other, because that's why they're amino acid. One amino acid reacts with another amino acid, forming what? Protein molecule. They form this polymer, isn't it? So we are going to take that polymer, that protein polymer, going to place it inside, let's say, some sort of like you have seen the experiments done on the glass cubes. I'm not sure what they're called, but they're like, let's consider them as glass cube. So in those glass cube, you tend to like place droplets of sample or bloods, and then you examine by observing them through microscopes. So they're, let's say, kept on those like glass beads or glass cubes, and they're like this protein, they're actually made to undergo hydrolysis reaction, because hydrolysis do what? In hydrolysis reaction, larger molecules break up to form the smaller molecules from where they were produced. So these are the molecules or the monomers which we'll be getting by hydrolyzing this. And these monomers were the monomers which joined together or combined and reacted together to form this large molecule or the polymer. And the hydrolysis will be done in presence of what? H plus aqueous. That means any sort of acid in like will be enough. Okay, so H plus, or let's say direct, let's say I'm mentioning a hydrochloric acid could be here. Or we can also do is what? We can also do alkaline hydrolysis. Okay, remember there are two types of hydrolysis. One is acidic hydrolysis, another is alkaline hydrolysis. So OH minus plus heat. Now there will be some difference between them. What are the differences? We will be like coming to back to that in a short while, but let's see actually how the experiment work or how the apparatus are being set. So we have, let's say, some sort of some sort of beaker here, let's say, or some sort of container here. This is a container, let's say. This has some solution in it, and we have another container, let's say, over here. Okay, so we have another container here, and we have, let's say, some solution, like sort of like a beaker or some sort of like any vessel which can hold some liquid solution. And we place electrodes on two sides, and this is the cell, let's say. This is the cell. Okay, let's say this is the cell. This is a positive side, and that's the negative side. Let's consider one is positive, another is negative side. Let's draw it on the different part. This positive, that is negative. Okay. Now, this positive part is connected to that electrode. This negative part connected to this electrode. Finally, we have the glass bead part or the glass cube part. This is the glass cube, let's say. Okay, so and there's this filter paper which is soaked to the solution. Now, how this works? We place a glass. Let's say this is a glass. Okay, this is a glass block or the glass cube. Then we place a filter paper in between them. The thin filter paper, a piece of filter paper in between them. Just normal, let's say, how you place a paper, and then on top of that you place another glass plate. Okay, the glass block. So we sort of make a sandwich. Now what happens? This portion is submerged to one vessel, and this portion, I mean this part of the filter paper, is submerged into another vessel. Okay, and electricity is applied to those voltage, like those speakers. Now what happens is, or what we do is, we place the droplet of the sample over here. So this is the droplet of the sample, and this was the glass slide. So that's a glass slide. This is the solution, or we can say buffer solution. Specifically, the solution should be buffer solution. Remember buffer solution from the buffer solution topic, which we studied in our electrochemistry ionic equilibrium part. Okay, so if you can't remember, just go back to the buffer solution topic and have a quick recap. Like buffer solution helps to keep its pH value. If you add a tiny droplet of acid, it will try to reduce the effect. If you try to apply a little bit of alkali or base, it will also try to reduce the effect. Like it will try to prevent that interaction. Like it will try to defend itself, trying to keeping its position. Then we have this filter paper. This is the filter paper. Filter paper. Remember, you might be asked to draw the diagram, so no doubt in that. So filter paper which is soaked in buffer solution. Soaked in buffer solution. And this is a DC power supply. DC like this whole one is the DC power supply. Okay, yeah. Now, yeah, this was actually the mixture of amino acids. Mixture of amino acids. Okay. Like after hydrolysis, we get the sample and we place the sample on the top or on the filter paper, and placing the filter paper in between two glass slide, we submerge the filter paper into the 2 beaker or 2 buffer solution, applying electricity or electrolysis process. We do the conduct the reaction or the experiment. Now, let's do an example to see how things work actually over here. So let's say we have this glass bit there, and we have, let's say, the positive terminal on one side and negative terminal connected to the other side. Like, let's say, just drawing the actual like normal part, okay, just the concept. You know that there will be a beaker, there will be the filter paper, but let's consider that this is the glass bit and there's the terminals connected. So let's say this is the middle portion. We need to mark the middle portion, and at the very center, we're going to place that sample. This is the sample placed here. Okay, this is the mixture placed here. Okay, now based on certain thing, we will get, let's say, here one of the substance, then we could get here one of the substance. This is too dark. Here one of the substance, and finally we have, let's say, which color? Let's say orange, or let's say yellow, a golden color. So there's another portion. Okay, let's give it a bit closer. Okay, now these are the, like, after electrolysis we got this results. Okay, so like these are the results after the, let's say, the electrophoresis is done. We place the mixture and we got these distances. Now, what type of amino acid should be like? We are getting some amino acid. Amino acid itself does not have any color. Okay, so we will be having or spraying or applying some reagent, coloring, like identifying reagent, in order to visualize the color. Okay, some reagents are there, some like identifier are there. Okay, those will work in order to like visualize, or let's say like make the amino acid colored compounds. Why? Because they are going to react with those amino acids and making them appear on the, or the dyes will appear on the filter paper. Dyes means the like the colored droplets. So amino acids, we have, let's say, relative sizes. I will explain this, don't worry. And we have the charges. So what is happening here? Let's say amino acid A, B, and C are marked here. Let's say this is A, this is B, and this is the C. Okay, so these are the amino acids we found after the experiment. Now, what sort of changes happen and what type of like thing happened here? We have to just identify them. In this case, we are not unable to, like, let's say, we don't need to completely identify what is this molecule. Rather, we have to say or describe the situation. So amino acids change from the mixture point was how much, like compared to other molecule, other mixture. This is the largest, isn't it? From here to the corner, like this portion, compared to B. B was in this much and C was this much. So which one have the largest difference? Obviously A, isn't it? So this is the, let's say, the largest traveled. That means what? Remember one thing. Let's say I am 110 kilos or 150 kilos. And in another situation, I am 50 kilos, just 50 kilos. Which one of these two situations I will be able to move faster or move much more longer, travel longer distance? Obviously, which one is lesser mass? Or let's say I'm in this place, I'm on, let's say this is a cart, a trolley cart. In one situation I have 150 kilogram of mass, another situation I have, let's say, just 50 kilogram of mass. Which one will I be able to move and like make it travel farther. Obviously, the one with the smaller distance, that will be much more easier to make it travel, isn't it? At a given time period, I'll be able to push it farther apart than this one, because this one will create more opposing force. Similarly, consider here, which one do you think have the larger mass? Obviously, the one which travel the shortest distance has the largest mass, isn't it? That means this is the largest of all, largest, okay, or the large one. Then which one is the shortest, like the smaller molecule? The one travel the largest distance or the most distance, that means A is the has traveled the greatest distance, so A is the smallest one or smaller one. Finally, we have one. Obviously, there is another term C, or like another component C. We have to mention it. Let's say if we are comparing them, C lies somewhere in between because it travels somewhere in middle. So let's say it is medium sized. Okay. Now, in which like direction did they move? A and B move towards which terminal? Towards the positive terminal. That means A and have what charge? What charges is attracted by positive charge? The opposite charges. That means what? Negative charges will be attracted by positive terminal. So A and B have what charge? Obviously negative charge. C is moved towards which one? Negative terminal. That means C have which charge? Positive. Makes sense? So I hope this was easy for you. It's not easy, so it's easy. I'm sorry, like my tongue is getting twisted. Now let's do some couple of more examples to see what type of or what other type of like questions can appear. So they're saying the question mentions electrophoresis on a mixture of the amino acid glycine, and is that pH7? Okay, so they're saying electrophoresis is done on a mixture. It is done on a mixture of amino acids, glycine. They're mentioning what sort of like amino acids are present there. Glycine is there, lysine is there, lysine is there, and glutamic acid is there. Glutamic acid is there. Do we have a structure for glutamic acid? Just a second, let me see. Did we study glutamic acid? No, we didn't study glutamic acid. We studied aspartic acid, but they have given us glutamic acid. So glutamic acid, how it looks, the structure will be given. Just a minute, I will be giving the structure. So these are the acid. This acid at pH 7. Okay, these are the informations given here that we are doing electrophoresis on the mixture of amino acid containing this glycine, lysine, and glutamic acid on pH 7. Like the pH is now in 7. That means they're neutral in such condition. They have like they're combined with each other. Glycine, we know the structure is what glycine is. The R group is the H, isn't it? The R is the H group. Then we have lysine. Lysine, we also know that the R group is what? CH2, 4 and H2, isn't it? From our previous like lectures. And we have glutamic acid, which was we didn't learn, but don't worry. In such situation where if let's say in data booklet or you like in data booklet, if those things are not given, they will give you the structures. Glutamic acid has a R group. The R group should be CH2. Remember, we just learned aspartic acid, which just has one CH2. In this case, we have two CH2 and a carboxylic acid. Okay. So this is our glutamic acid. Now we need to find what should be the what should be the position, what should be the like solution, like how should they like look like in situations, let's say, I mean, what should be the overall charge of each of them in this situation? Like we have to draw their structures in this situation, like after the reaction has been done. So let me also help with this solution. I'm not I would like after solving this, you will do it by yourself again. Try to like do the concepts as well, like rewind the concepts as well. So at pH 7, initially, since they have mentioned pH 7, so at pH 7, what could be the situation of the molecules? So Think of glycine. Glycine, how does it look like? Glycine looks like NH2, we have CH2, we have COOH, isn't it? This is how it looks like. At pH 7, what should it look like? Just try to observe. At pH 7, that means what? Obviously, like all the things are going to be like they have come to like in the like pH 7 means they have all reacted and all done everything. What should they look like now? So glycine should look like this, that this H will be this carboxylic acid. What is it prone to? This is prone to like donating hydrogen plus H plus, and this NH2 is what? This is willing to absorb H plus. That means it's willing to get an H plus. That means here, what will happen in the equilibrium or the pH 7 is this will gain a H plus, and we have this H, and the hydrogen which has been traveling or which has been received by NH2 is this from carboxylic acid. That means what? Overall charge is this O minus and this N plus, isn't it? NH3 plus. That means overall charge is what of this total entire molecule? Here, it donated an electron to the solution. Let's say they were in the solution. It donated not an electron, it donated a hydrogen H plus ion, and this gained an H plus ion. That means what happened? This is O minus, this is N plus. The overall charge is what? Overall charge is minus plus 1, minus 1 and plus 1. That means 0. Overall charge equals to 0. Okay, so that's how the structure, like they are willing you to like answer the questions. Then we have what? We have lysine. Lysine means we initially had, let's say, NH2, H, and there's the CH2, 4, NH2. We have COH. Now, what should this like happen? Think of all the possible NH2 and carboxylic acid, like amine and carboxylic acid groups. Okay, think of all those. Even if alcohol was present there, think of all those. So like we are trying to form what? Ions here. So carboxylic acid is willing to donate H plus. It will donate H plus, fine. Amine is willing to what? Gain H plus. Also think of the side chain. What is this? This is an amine. This is willing to gain H plus. Then what will happen? This NH2 will gain a H plus, so NH3 plus. This NH2 to the side chain is willing to gain an H plus. That means what? NH3 plus, isn't it? Finally, we have what? Carboxylic acid, which is willing to donate H plus, so O minus. That means now overall charge is what? A plus charge, like 2 plus charges and 1 minus. That means 2 plus, plus 2 minus 1. That means what? Overall is plus 1. Overall equals plus 2 minus 1 equals to plus 1, isn't it? Like, does it make sense? I hope it makes sense. And the last one is glutamic acid. We will try to draw it because we don't know already like how it works, like how we haven't learned it, but since they have given us the structures, so it will be easier for us. So glutamic acid, how does it look like? Let's see. So we should have a NH2 group. There's this H group, and there should be an R group. R group is given, they have given us that this is CH2 2 times present, and we have this carboxylic acid. And we have the carboxylic acid here. Now, when it reacts, what happens? Or when it donates, gains electrons, what happens? This carboxylic acid is willing to donate H plus. This NH2, which is amine, is willing to gain H plus. However, this carboxylic acid, that's also willing to donate H plus. Let's see what should happen. That this NH2 amine should gain H plus, so NH3 plus, and there's this H group. Then this carboxylic acid donating H plus, so COO minus, and this carboxylic acid as well is donating an H plus, so COO minus. Now see what's the overall charge. Overall charge is given as 2 minus 1, that is minus 2, plus 1, a single positive 1. That means minus 1. Overall charge is what? Minus 1. Got it? So we got, or we understood how things should look like. Now they're saying that now draw their position in the like electrophoresis state, like in the glass slide, in the filter paper after the electrolysis have conducted, what should their state look like? Let's say this is the plus and this is the minus part, and we had placed this sample over here somewhere in middle. After the electrophoresis happened or occurred, let's say they have given us 3 possible positions. Let's say they have given us 3 possible positions. One is R, another is S, another T. This is the position after the electrophoresis have been done. Now your work is to find this R, S, and T. That's why we did so like those things to identify which molecule is present in which portion. Now observe this and say what justifies, what should justify which molecule should be in which position. Now this portion, try it by yourself. Pause the video and try it by yourself. Okay, let's see. R is towards which terminal? Positive. That means what? Positive terminal attracts which molecule? Negative terminal, like negative molecule, the ones which are negatively charged. So which one of them has overall charge of negative charge? This one, which is glutamic acid. That means R is what? Glutamic acid. Makes sense? If you weren't able to solve this one, so you got it now. Now try for the rest of the two. What should be S and T? S is in the middle. That means what? Where the sample was placed. That means both positive, negative won't have any effect. That means this is neutral. So we have overall charge of 0, which is our glycine. That means S is what? Glycine. I would also urge, if you couldn't solve this one as well, try to solve the last one, which is T. Okay. So T is on the negative terminal, like towards the negative terminal. That means what? T should have an overall charge of positive 1. We have which one? We have lysine as the positive, like the positive charged one. So lysine is going to be attracted by the negative terminal. Okay. So this sort of question, it comes in the question, like it comes in the exam. So you would have to draw, or you have to like, visualize in the, let's say if the pH is 7, that means what? Since the pH is 7, that means all are neutral. In such a neutral condition, what should have happened? The acidic and the basic components would have reacted with each other, isn't it? And we know what? They've given us the structures. That means in each of the condition, what will each of them do? One will gain H plus, another will like lose H plus, isn't it? So that's what is happening, and we are drawing, or we are sketching or observing what is happening in the like process, like what are the charges, how are they structured, what are the conditions there. So we have drawn the conditions, how they are, like how could they stay there, and like visualizing that this might be their structure in that situation, where they can travel. Based on their overall charge, we are able to answer that where they traveled. Okay. Now let's do another example. Yeah, let's do another example. So they are asking us to draw the structure of the tripeptide Ala-Ser-Gly. That means what? Alanine, serine, and glycine. Okay. In the second question, they're asking us calculate the MR of Ala-Ser-Gly. So alanine, serine, and glycine, that peptide, the tripeptides, MR you should be able to calculate. Finally, they're saying a mixture of the tripeptide and its 3 convenient amino acid was subjected to electrophoresis in a buffer solution pH 11, sorry. Okay, so that means this alanine, serine, and glycine, they're made to undergo electrophoresis. Electrophoresis is done on them at pH equals to 11. Okay. I mean the buffer solution. The buffer solution was at pH 11. Buffer solution was at pH 11. So initially, the previous example, the buffer solution was actually in pH 7. I'm sorry, I didn't mention. So that was the pH of the buffer solution. And here, the pH of the buffer solution is what? 11. Now, we have to draw the structure at pH 11. So draw their structure at pH equals to 11. Their structure means separately alanines, serines, and glycine. Okay, each of their structures you should have drawn just like the previous one, just like this one. Okay, you have to draw it in this case, but remember here we have now what pH 11 is given. Finally, you have to like identify the result of the electrophoresis. So result of electrophoresis. Okay, so they have given you, let's say, this, like you have to label the diagram. Also you have to draw which component is which one. Let's say this is the portion given, so F is given here. You have to, like, they have mentioned what are each of them. So this is, let's say, these are the 2 points they are connected to. What is this point? This is G. Let's say this is H. We have, let's say, this is, let's say this is, they're mentioning that I. This is in the center, which is mixture, and this is, let's say, S. This is R. This is Q, and this is P. Okay, try to pause the video and do it by yourself. Just apply, just try to think what could have been happened. Obviously the first one you can easily solve by yourself. See the structures, and remember the bonding should be formed between the main chain, not the side chain in this case. Okay, so draw the structure of the tripeptide. After forming the bond, I mean, you have formed the bond, the structure. Now count how many carbons are there, how many, like, based on that, calculate the MR. Okay, MR is which one? MR is their relative molecular mass. Then that means each of the atoms mass, specific atomic mass of each of the atoms, you are going to add them up. Okay, that's the MR, that mass of one molecule of this whole molecule. Then in C you will get, you have to draw the structures as like the previous example, and in D we will identifying the parts. I hope you have solved it or tried to solve it. No worries, I'll be giving the solution now. So the first one should look like this. We have alanine first, so CH3 group present here, which is the R group. Then we have this carboxylic, the peptide linkage, and now the part for the serine, isn't it? Yes, alanine serine. So serine, we have hydrogen, CH2OH, the alcohol, the R group. This is the R group. Then we have this carboxylic acid group again. Is it the carboxylic acid? Yes, carboxylic acid. Then we have finally the glycines part, which is the amine is present here. The C with simple H's, H will be there. This is the R group. Finally, we have this carboxylic acid. Okay. So this is the structure of the tripeptide due to alanine, glycine, and serine. Now, based on this structure, let's count how many carbon, nitrogen, oxygen, and like hydrogen is there. Carbon number 1, 2, 3, 4, 5, 6, 7, 8. So C is 8, isn't it? 1, 2, 3, 4, 5, 6, 7, 8. C8, then how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. H15, we have oxygen, how many? 1, 2, there is this 3, 4, 5, isn't it? 1, 2, 3, 4, 5. So oxygen is 5 and nitrogen is 1, 2, 3. So 3 nitrogen. Okay, now let's calculate. So each carbon has a mass of what? 12, isn't it? 12 times 8 carbon plus we have what? Hydrogen. Each hydrogen has a mass of 1, so 1 into 15 plus oxygen. Each oxygen has a mass of what? Each oxygen. Each oxygen has a mass of 16 times 5 plus nitrogen, which is 14 times 3. Now, if we add them up, we should get something near 233. If I'm wrong, please mention it on the comments. So then we have C. If like I would have like I would then correctify myself. Let me just clarify by myself once. 14 into 3 plus 1 into 15 plus 16 into 5 plus 14 into, sorry, 12 into 8. Yes, 233. Now at pH 7, what is the solution there? Like, what is the condition actually present there? At pH 7, we know the solution is what? Alkaline, because pH is 7. pH 7 means what? Sorry, pH 11. Sorry, pH 11 means what? Alkaline. Like, I'm actually describing the situation here. So what can actually happen? So amino acids in the alkaline solution shows what type of change? Alkaline solution means what? It must have like more number, like more willing to, like it will have surplus of H plus, isn't it? H plus will be gone. Like, try to think it in this way. Like carboxylic acid will be less in portion. That means what? More will be, the overall charge will be what? Overall charge will be like positive, isn't it? If less carboxylic, how do I explain? Like, think it in this way. In the given diagram here, okay, in the given diagram here, which way PQRS are going to? PQRS are going towards which one? G terminal. Now, what should be our like overall charge of each of the molecules? Each of the molecule, or like, since the solution is pH 11, that means our overall charge should be a positive charge. While in case of pH 7, what did we see? Overall charge of all the molecules were what? They neutralized themselves, because one was positively charged, one's overall charge, another was negatively, and was 0. That means what? +1, -1, like they, if we add them up, what should we get? We should get an overall charge of what? 0. That means neutral, pH 7. That's why they like see, they were equally distributed. R was on the left, T was on the right, S was on the middle. So we can see equally distribution. But here, see, in one of the side, PQRS, all of them troubled. That means there is a specific charge, but what should it be? Since pH is 11, that means the amino acid should show a positive charge. That means what? If it is negative, it should show a negative charge. I mean, sorry, this pH is lesser. pH, if pH is less than 7, okay, pH is less than 7, then amino acids show minus charge. If pH greater than 7, then charge is what? Positive. That means alkali, towards alkali it is positive. And pH equals to 0, 7 means what? Overall charge. I mean, total of all the charges, all the like adding up all the overall charges of each of the ions. We will have what? We will have like the charge should be, overall charge should be 0. So in this case, since all of them are having a positive charge, that means they're moving towards G. So what should be the charge of G? This should be the negative terminal, isn't it? G negative terminal. That means H should be what? Positive terminal. H should be positive terminal. That means all of them are what? Like, what is the charge of PQRS? They're all positively charged. F is what? F is our DC circuit. I mean, sorry, DC supply, DC power supply. Okay. I is what? I, you can say, specify it's a filter paper. I mean, the glass containing the filter paper. I is filter paper. Okay. Now the rest of the portion, I leave it to you as the homework. In our next lecture, we will solve the PQRS. Who are PQRS? Okay. I will give it to you to find it by yourself. Okay. Take care. Allah Hafiz. Assalamu alaikum.